In this exercise, I'm going to be solving this system of simultaneous equations, and the first step is to get the system of simultaneous equations and write it as a matrix, and I have this done here. It's the augmented matrix with the right hand side here, and I put a line there to know where the equal sign is. So the first thing we're going to do is get a 0 in this position on the second row, first column. So this one here contains a 1, and we want to make it into a 0, so we're going to do minus row 1 plus row 2. That's going to give us our new row 2. The first row is not changing, so I just rewrote it, and now the second row is going to be replaced with the result of this operation, so minus 1 plus 1, 0, as we want it, minus 2 plus 4, 2, minus 1, minus 1, minus 2, and minus 3 plus 2, minus 1. Now for the third row, I'm going to do another step here between this one and this matrix here. I want to get a 0 in this position here. I have a 2, so I'm going to do minus 2 times row 1 plus row 3 is going to be our new row 3. So we're going to have minus 2 plus 2, 0. Minus 2 times 2 is minus 4, plus 1 is minus 3. Minus 2 times 1 is minus 2, minus 2, minus 4. Minus 2 times 3 is minus 6, plus 5, minus 1. At this point we have the first column finished. We have these two zeros down here below the diagonal. We're going to move into the second column. And the first thing I'm going to do is I'm going to replace this matrix with one where I'm going to divide the second row by 2, so I get a 1 in this pivot position. So row 1 and row 3 are not going to change, and we're going to replace that second row with the result of dividing by 2 every element in the second row. So 0 divided by 2, 0, 2 divided by 2, 1 as we wanted, minus 2 divided by 2, minus 1, and minus 1 divided by 2 is minus a half. Now we have this 1 in the pivot position, and we can cancel this minus 3. We want to get a 0 in this position for the minus 3. So we're going to do 3 times row 2 plus row 3 is going to be our new row 3. So I have rewritten row 1 and row 2 because they're not going to be changing. Now our new values for row 3 are going to be 3 times row 2. So 3 times 0 plus 0 is 0. Nothing changes. 3 times 1 is 3, minus 3 is 0 as we wanted. 3 times minus 1 is minus 3, minus 4 is minus 7, and 3 times minus a half is minus 3 over 2, minus 1 is going to be minus 5 over 2. And at this point, if we look here, we have our 3 zeros below the diagonal, so every value below the diagonal is 0. So we can now solve using, starting from the last row, solving for z. So minus 7 z equals minus 5 over 2. Once we calculate the value of z, we'll go into the second row, calculate for y, and then we'll go into the first row and calculate for x. It's 0.35. We're going to the second row now. I'm going to go down here, and we know that y minus z, which is 0.35, equals minus 0.5. Therefore y is going to be equal to minus 0.5 plus 0.35. So minus 0.15. And then we go into the first row and we calculate x. I'm going to put a line here. X is going to be equal to, and I'm going to move everything to right hand side already, 3 minus z minus 2 times y, which is minus 0.15, so this becomes plus 0.15. So x equals 295. And this is the solution. The x value here, the z value here, and So x equals 295, y equals minus 0.15, and z equals 0.35.